Part A, 4 divided by x plus 8 divided by x squared. What's different here? We do not have like denominators, and we don't have a real easy way like we did in the last problem to get them alike. I mean, it's not too hard, but it's different. The way we're going to get common denominators here is different than what we did in the last problem. Okay, so we need, let's do a preliminary example. Let's go back, and you can do this on your own. When you're having trouble understanding something, go back to numbers, because we're all a little bit more comfortable with numbers than we are with letters acting like numbers. So let's say you want to add 2/3 and pick something with that's not the same a fraction that doesn't have a denominator of 3. Let's pick, how about 1/5? Oh, even better for this example, how about we make it 1/6? Because it'll be more like this example if we do that. So 2/3 plus 1/6. What do we need to add those two guys together? Well, yeah, but what do we call that? We call it a common denominator. We actually call it the least common denominator. We need to find the least common denominator and then get both fractions in terms of the least common denominator. The least common denominator is simply, when it comes to numbers, it's the least common multiple of the denominators, right? So what's the smallest number when you think least common multiple or least common denominator? What's the smallest number that both of these guys divide into evenly? Or put another way, what's the smallest number that contains both a factor of 3 and a factor of 6? 6. I mean, you could take 3 times 6, but that'd be too big. It wouldn't be the least common denominator, right? Or you could take 12, but that would be too big. It wouldn't be the least common denominator. The least common denominator would be 6. So the LCD of 3 and 6, that's some notation that a lot of books use. LCD, parentheses, 3 and 6, would be 6. And so I know you guys know how to do this, but I want you to analyze the thought process here. 1/6 is good to go. It has the LCD, right? We need to get 2/3 in terms of that LCD. So what do? You multiply the numerator and denominator of 2/3 by the factor it's missing from the LCD. Have you ever thought of it that way? So 6 is 2 times 3, right? If you factor 6, you get 2 times 3. So which of these two factors is this denominator missing? It's missing the 2. So you're going to multiply numerator and denominator of the 2/3 by 2. Now, when you multiply numerator and denominator by the same thing, what are you really multiplying by? 2/2 is really what number? 1. When you multiply by 1, are you changing the value? No. So really what we're doing is we're unreducing. You guys are used to reducing fractions, right? We're unreducing 2/3. We're making it 4/6. That's another way to think of it. So you multiply straight across, you get 4/6 plus 1/6. And what does that turn out to be? 5/6. Now you guys all knew how to do that. But the point isn't that you know how to do that. The point is analyzing what you're doing so you remember the process. And not everybody remembers the process. You just have done it so many times you don't even think about it. Now, what we're going to do down here is exactly the same thing. So let's take a look. So in part A, we have 4 divided by x plus 8 divided by x squared. Okay, first you have to find the LCD, right? Technically, I don't know if it'll come up too much, but if one of these weren't reduced all the way, you might want to simplify it first, but that's not an issue here, right? I'll give you an example. So what if you had, like, instead of 8 over x squared, you had 8 over 2x squared? The 2 would go into the 8 and make 4, right? Simplify it first. Not an issue here, but just be aware of stuff like that. Okay. Do you guys remember how to find the LCD? That's what we need, right, to add these two fractions together. We have x and x squared as our denominators. They're not the same. All right, so when it comes to polynomials, the LCD is the smallest degree polynomial that contains all the factors of all the denominators involved. Okay? When you have powers of the same variable, it's just going to be the higher of the two powers. So the LCD, and that trick works every time. So you have x to the 1 power here. You don't see the 1. You have x squared here. The LCD is going to be x squared. It's going to be the higher power. That trick works every time. So, so the LCD of x and x squared is just going to be the higher power of x squared. So, okay, 8 over x squared is good to go, isn't it? What do I do to 4 over x to get it in terms of x squared in the denominator? Okay, so no, not square, no. So you have 4 over x. You need to multiply the numerator and denominator by something. This is supposed to look like a big old 1. You need to multiply the numerator and denominator by the same thing, because that'll make it a 1, right? And it's going to be the factor that's missing from the LCD. So if you think about it, x squared is x times x, right? What factor is this guy missing from the LCD? It's missing a factor of x. You need to multiply numerator and denominator of 4 over x by x. X over x. Oh, x divided by x is 1. You're multiplying by 1. You're not changing the value. So you're going to multiply by 1, just like we did up here to get 2/3 in terms of sixth, a denominator of 6. Okay, and then, you know, the 8 over x squared, that doesn't change. Okay, multiply straight across, what do you get? 4x over x squared plus 8 over x squared, and you add these guys together. Get a little bit of room here. So you combine the numerators. What do you get when you combine the numerators? Yeah, now this is one where you truly have to show this, 4x plus 8, because they're not like terms. In fact, you have to leave it like that, don't you? So you get 4x plus 8. So you combine the numerators, keep the common denominator. It is the same thing as we do with numbers, isn't it? I mean, think about it. The steps are the same. Now, we can't combine 4x and 8. So we got to just leave it like that. Someone might say, can we factor out a 4? Yes, but does it do you any good? If you had a factor of 4 or 2 in the denominator, yes, factor out the 4, simplify. Here it doesn't do you any good. There's no common factors in the numerator or denominator, so there's no reason to factor the numerator.